reliable are climate models? Science says, models successfully reproduce global temperature since 1900. Climate models are mathematical representations of the interactions between the atmosphere, oceans, land surface, ice, and the sun. This is clearly a very complex task, so models are built to estimate trends rather than events. For example, a climate model can tell you it will be cold in winter, but it can't tell you what the temperature will be on a specific day. That's weather forecasting. Climate is weather averaged out over time, usually 30 years. Trends are important because they smooth out single events that may be extreme, but quite rare. Climate models have to be tested to find out if they work. We can't wait for 30 years to see if a model is any good or not. Models are tested against the past, against what we know happened. If a model can correctly predict trends from a starting point somewhere in the past, we could expect it to predict with reasonable certainty what might happen in the future. So all models are first tested in a process called hindcasting. The models used to predict future global warming can accurately map past climate changes. If they get the past right, there is no reason to think their predictions would be wrong. Testing models against the existing instrumental record suggested CO2 must cause global warming, because the models could not simulate what had already happened unless the extra CO2 was added to the model. All other known forcings are adequate in explaining temperature variations prior to the rise in temperature over the last 30 years, while none of them are capable of explaining the rise in the past 30 years. CO2 does explain that rise, and explains it completely without any need for additional, as yet unknown forcings. Where models have been running for sufficient time, they have also been proved to make accurate predictions. For example, the eruption of Mount Pinatubo allowed modelers to test the accuracy of models by feeding in the data about the eruption. The models successfully predicted the climatic response after the eruption. Models also correctly predicted other effects subsequently confirmed by observation, including greater warming in the Arctic and over land, greater warming at night, and stratospheric cooling. Does global warming have an upside? Science says, negative impacts of global warming on agriculture, health, and environment far outweigh any positives. Agriculture. While CO2 is essential for plant growth, all agriculture depends also on steady water supplies, and climate change is likely to disrupt those supplies through floods and droughts. It has been suggested that higher latitudes, Siberia, for example, may become productive due to global warming, but the soil in Arctic and bordering territories is very poor, and the amount of sunlight reaching the ground in summer will not change because it is governed by the tilt of the Earth. Agriculture can also be disrupted by wildfires and changes in seasonal periodicity, which is already taking place, and changes to grasslands and water supplies could impact grazing and welfare of domestic livestock. Increased warming may also have a greater effect on countries whose climate is already near or at a temperature limit over which yields reduce or crops fail, in the tropics or sub-Sahara, for example. Health. Warmer winters would mean fewer deaths, particularly among vulnerable groups like the aged. However, the same groups are also vulnerable to additional heat, and deaths attributable to heat waves are expected to be approximately 5 times as great as winter deaths prevented. It is widely believed that warmer climes will encourage migration of disease-bearing insects like mosquitoes, and malaria is already appearing in places it hasn't been seen before. Polar melting. While the opening of a year-round ice-free Arctic passage between the Atlantic and Pacific Oceans would confer some commercial benefits, these are considerably outweighed by the negatives. Detrimental effects include loss of polar bear habitat and increased mobile ice hazards to shipping. The loss of ice albedo, the reflection of heat, causing the ocean to absorb more heat, is also a positive feedback. The warming waters increase glacier and Greenland ice cap melt, as well as raising the temperature of Arctic tundra, which then releases methane, a very potent greenhouse gas, Methane is also released from the seabed, where it is trapped in ice crystals called clathrates. Melting of the Antarctic ice shelves is predicted to add further to sea level rise with no benefits accruing. Ocean acidification. A cause for considerable concern. There appear to be no benefits to the change in pH of the oceans. This process is caused by additional CO2 being absorbed in the water, and may have severe destabilizing effects on the entire oceanic food chain. Melting glaciers. The effects of glaciers melting are largely detrimental, the principal impact being that many millions of people, 1/6 of the world's population, depend on fresh water supplied each year by natural spring melt and regrowth cycles, and those water supplies, drinking water, agriculture, may fail. Sea level rise. Many parts of the world are low-lying and will be severely affected by modest sea rises. Rice paddies are being inundated with salt water, which destroys the crops. Seawater is contaminating rivers as it mixes with fresh water further upstream, and aquifers are becoming polluted. Given that the IPCC did not include meltwater from the Greenland and Antarctic ice caps due to uncertainties at that time, estimates of sea level rise are feared to considerably underestimate the scale of the problem. There are no proposed benefits to sea level rise. Environmental. Positive effects of climate change may include greener rainforests and enhanced plant growth in the Amazon, increased vegetation in northern latitudes, and possible increases in plankton biomass in some parts of the ocean. Negative responses may include further growth of oxygen-poor ocean zones, contamination or exhaustion of fresh water, increased incidence of natural fires, extensive vegetation die-off due to droughts, increased risk of coral extinction, decline in global phytoplankton, changes in migration patterns of birds and animals, changes in seasonal periodicity, disruption to food chains and species loss. Economic. The economic impacts of climate change may be catastrophic, while there have been very few benefits projected at all. The Stern report made clear the overall pattern of economic distress, and while the specific numbers may be contested, the costs of climate change were far in excess of the costs of preventing it. Certain scenarios projected in the IPCC AR4 report would witness massive migration as low-lying countries were flooded. Disruptions to global trade, transport, energy supplies and labor markets, banking and finance, investment and insurance, would all wreak havoc on the stability of both developed and developing nations. Markets would endure increased volatility, and institutional investors such as pension funds and insurance companies would experience considerable difficulty. Developing countries, some of which are already embroiled in military conflict, may be drawn into larger and more protracted disputes over water, energy supplies or food, all of which may disrupt economic growth at a time when developing countries are beset by more egregious manifestations of climate change. It is widely accepted that the detrimental effects of climate change will be visited largely on the countries least equipped to adapt, socially or economically. Do scientists agree about global warming? Science says, 97% of climate experts agree humans are causing global warming. Science achieves a consensus when scientists stop debating. When a question is first asked, like what would happen if we put a load more CO2 in the atmosphere? There may be many hypotheses about cause and effect. Over a period of time, each idea is tested and retested, the scientific method, because reputation and kudos go to those who find the right answer. Nearly all hypotheses will fall by the wayside during this testing period, because only one is going to answer the question properly, without leaving all kinds of odd dangling bits that don't quite add up. Bad theories are usually rather untidy. Eventually, the testing period must come to an end. The focus of investigation narrows down to those avenues that continue to make sense, that still add up, and quite often a good theory will reveal additional answers, or make powerful predictions that add substance to the theory. When Russian scientist Dmitry Mendeleev constructed the periodic table of elements, not only did he fit all known elements successfully, he predicted that elements we didn't even know about would turn up later on, and they did. So a consensus in science is different from a political one. There is no vote. Scientists give up the debate because the sheer weight of consistent evidence is too compelling, the tide too strong to swim against any longer. Scientists change their minds on the basis of the evidence, and a consensus emerges over time. Not only do scientists stop debating, they also start relying on each other's work. All science depends on that which precedes it, and when one scientist builds on the work of another, he acknowledges the work of others through citations. The work that forms the foundation of climate change science is cited with great frequency by many other scientists, demonstrating that the theory is widely accepted and relied upon. In the field of climate studies, which is informed by many different disciplines, the consensus is demonstrated by the number of scientists who have stopped debating what is causing climate change, and that's nearly all of them. A survey of all peer-reviewed papers on the subject global climate change published between 1993 and 2003 shows that not a single paper rejected the consensus position that global warming is man-made. 75% of the papers agreed with the consensus position while 25% made no comment either way, focusing on methods analysis instead, or ESC's 2004. Several subsequent studies confirm that the debate on the authenticity of global warming and the role played by human activity is largely non-existent among those who understand the nuances and scientific basis of long-term climate processes. Durant 2009, in other words, more than 95% of scientists working in the disciplines contributing to studies of our climate, accept that climate change is almost certainly being caused by human activities. We should also consider official scientific institutions and what they think about climate change. There are no national or major scientific institutions anywhere in the world that dispute the theory of anthropogenic climate change. Not one. In the field of climate science, the consensus is unequivocal: human activities are causing climate change. Can animals and plants adapt to global warming? Science says, global change is happening too fast for the ecosystem to adapt. Humans are transforming the global environment. Great swathes of temperate forest in Europe, Asia, and North America have been cleared over the past few centuries for agriculture, timber, and urban development. Tropical forests are now on the front line. Human-assisted species invasions of pests, competitors, and predators are rising exponentially, and overexploitation of fisheries and forest animals for bushmeat continues to be the rule rather than the exception. Given these existing pressures and upheavals, it is a reasonable question to ask whether global warming will make any further meaningful contribution to this mess. Some see no danger at all, maintaining that a warmer planet will be beneficial for mankind and other species on the planet, and that corals, trees, birds, mammals, and butterflies are adapting well to the routine reality of changing climate. However, global warming has already affected the ecosystem by changing where some species can survive, the timing of breeding, migration, flowering, and so on. Although it's difficult to predict the future extinction risk, some scientists have found that 18 to 35% of plant and animal species will be committed to extinction by 2050 due to climate change. Are surface temperature records reliable? Science says, the warming trend is the same in rural and urban areas, measured by thermometers and satellites. Surveys of weather stations in the USA have indicated that some of them are not cited as well as they could be. This calls into question the quality of their readings. However, when processing their data, the organizations which collect the readings take into account any local heating or cooling effects, such as might be caused by a weather station being located near buildings or near tarmacs at an airport. This is done For instance, by weighting, adjusting, readings after comparing them against those from more rural weather stations nearby. More importantly, for the purpose of establishing a temperature trend, the relative level of single readings is less important than whether the pattern of all readings from all stations taken together is increasing, decreasing, or staying the same from year to year. Furthermore, since this question was first raised, research has established that any error that can be attributed to poor sighting of weather stations is not enough to produce a significant variation in the overall warming trend being observed. Even groups that have recreated the global temperature record on their own, with the intent to prove that there are problems with the data, have admitted that there is no substance to the claim. It's also vital to realize that climate change not based simply on ground-level temperature records. Other, completely independent temperature data compiled from weather balloons, satellite measurements, and from sea and ocean temperature records, also tell a remarkably similar warming story. Confidence in climate science depends on the correlation of many sets of these data from many different sources in order to produce conclusive evidence of a global trend. And, is Antarctica gaining ice? Science says, satellites measure Antarctica is gaining sea ice but losing land ice at an accelerating rate, which has implications for sea level rise. Skeptic arguments that Antarctica is gaining ice frequently hinge on an error of omission, namely ignoring the difference between land ice and sea ice. In glaciology, and particularly with respect to Antarctic ice, not all things are created equal. Let us consider the following differences. Antarctic land ice is the ice which has accumulated over thousands of years on the Antarctic landmass itself through snowfall. This land ice therefore is actually stored ocean water that once fell as precipitation. Sea ice in Antarctica is quite different, as it is generally considered to be ice which forms in salt water primarily during the winter months. Is the sun causing global warming? Science says, in the last 35 years of global warming, sun and climate have been going in opposite directions. Over the last 30 years of global warming, the sun has shown a slight cooling trend. Sun and climate are going in opposite directions. This has led a number of scientists independently concluding that the sun cannot be the cause of recent global warming. One of the most common and persistent climate myths is that the sun is the cause. This argument is made by cherry-picking the data, showing past periods when sun and climate move together but ignoring the last few decades when the two diverge. What does past climate change tell us about global warming? Science says, climate reacts to whatever forces it to change. Humans are now the dominant force. A common skeptic argument is that climate has changed naturally in the past, long before SUVs and coal-fired power plants, so therefore humans cannot be causing global warming now. Interestingly, the peer-reviewed research into past climate change comes to the opposite conclusion. To understand this, first you have to ask why climate has changed in the past. It doesn't happen by magic. Climate changes when it's forced to change. When our planet suffers an energy imbalance and gains or loses heat, global temperature changes. There are a number of different forces which can influence the Earth's climate. When the sun gets brighter, the planet receives more energy and warms. When volcanoes erupt, they emit particles into the atmosphere which reflect sunlight, and the planet cools. When there are more greenhouse gases in the atmosphere, the planet warms. These effects are referred to as external forcings because by changing the planet's energy balance, they force climate to change.